Hello, Climate Match students. In this video, I'm going to tell you about Project Pythia, a community-owned training resource for geoscientists learning the Python scientific ecosystem. Students who are less familiar with coding or with coding in Python may want to work through some pre-course exercises to learn Python basics. The Project Pythia Learning Portal covers basics such as environmental setup and your standard data types or loops, all the way up to tools for parallel processing of big data, such as X-ray and Dask. Let's go take a look at the site. First, we start out on the Project Pythia portal. Here you can read more about the project or the larger Pangeo community. Pangeo and Project Pythia are committed to open source principles and encouraging scientists to share their workflow and tools so that we can all spend less time struggling with the same software challenges as each other and more time on the scientific questions that get us excited about our work. We do this by empowering our community with educational tools so they can use the current best practices within Python so that they can work with geoscience data, and we empower them with the knowledge on how to contribute to this open source ecosystem. You can navigate the site either from the top nav bar up here, or you can scroll down where you'll see that we have several pillars to our learning material. The first one that you'll probably spend the most time with is the Project Pythia Foundations book. So this is a series of Jupyter notebooks. You can learn more about Jupyter here. That take you through learning Python basics from your environmental setup, different places you might want to install Python, some of the first packages you might encounter as a Python learner, such as NumPy, which is one of the fundamental packages for working with arrays of data, Matplotlib, which is kind of your go-to plotting library. CotterPy is an extension of this that is good for working with maps. Pandas and Xarray are then for working with larger data frames of data. And I encourage you to read through this book based on your own skill level, knowledge of coding in general or of coding in Python, and navigate by your own curiosity as you go through this. The next resource we have is cookbooks. So these are end-to-end workflows that show how to use these tools and packages and different arguments and functions available within them, but in practice, in kind of a real-world example, maybe a smaller example than petabytes of data, but you can kind of go through these. You can sort by the type of workflow you're interested. Maybe you are mostly looking at oceanography or machine learning, and you can click on them. And there should be a couple lessons in here that you can also launch on Binder, which is more of an interactive on the cloud work environment. This is an ever-growing community library, and hopefully we'll have a couple more cookbooks in here by the time you're watching this video. Our next pillar that we have here is our resource gallery. This is a collection of Python learning resources from all across the web that we have found useful for geoscientist learning. So maybe it is the documentation from the package creators themselves. Maybe it's a tutorial that someone in the community gave, a textbook. All of these learning resources are free. And you can also filter them here by specifically if you want to learn about applications to a subfield of geoscience. Perhaps you'd prefer to passively watch a video or actively follow along with the video. You can choose based on what works for your learning style or engagement method at that time. And similarly, and perhaps most useful, you can say that you're focusing on learning about visualization and plotting, and just look at tools for specific packages such as NumPy. And I hope that this is very helpful for you in your Python learning journey. This is not a super comprehensive list, so we're always looking for more resources if you have an idea. Okay, let's go back to a portal for a second. Okay, we've covered these 3 resources. You'll see that we also have a tutorial series and some data collection of open public domain data that you can use for testing and exploring these tools. If you're interested in doing more with the Project Pythia team, there's information on how you can join or meet up with us after your Climate Match Academy summer. Thank you and happy learning.